So yesterday we were looking at a point P, and we said that went through the coordinate 1, 2. And then we created another point, we called that point Q. And we started with the value 2, and we plugged it into the function, we got 3. Because, again, our function f of x was equal to x squared plus 1. Oh, not 2, 3, but 2, 5. Everybody agree that was the first point we used? Mm-hmm. And then we changed. Instead of 2, we used 1.5. And this value right there, instead of 5, it became like 3.25. And then we changed that 1.5 to like 1.1, so on and so forth, didn't we? Okay? And we kept on finding the slope over and over again. And I'm going to challenge you, instead of Q being 2 and 5, let's allow Q to be this. Let's allow Q to be x. And then once you have x as your x value, what do you do to find your y value? You just plug it in, right? And so our y value becomes whatever the function is, x squared plus 1. So now if we write out our slope, we have y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Whoop, I'm sorry, messed up. Our second x value would be x minus x sub 1 will be 1. There we have it. So this is our new slope function, and the idea is as Q gets closer to P, or as our x values become closer to 1, as x gets closer to 1, the slope gets closer to 2. Okay, so in plain terms, as x gets closer to 1, the y, or the slope, gets closer to 2. And that's how we're determining the slope of a line that's tangent. Okay? Everybody got your calculator? Gotta take that calculator out or share with the person next to you, 1 to 2.
I'm gonna share my phone. Oh, okay, I swear, I don't know how to.
I will buy it. Is this going to be so? I'm going to move since 95 years.
I'm so I literally have my Chromebook charger in my backpack.
You've been summoned your daily.
I'm a little scared.
Okay, here we go. Find the equation for the line tangent to the curve y equals root of x plus 1 at x is equal to 8. So what I would like to do to start this problem off is I just want to get a general idea of what the graph looks like. So that way I can ensure that my graph is my slope is an appropriate estimation. What does the graph of root of x plus 1 look like? Yep, shifted to the left 1 unit. So we are going to look at this function at 8. With the person next to you right now, I would like you to describe in some way, shape, or form the slope of that function at 8. Go ahead, talk. Describe the slope at 8. Go. Okay, tell me something about the slope. The slope is it positive or negative? Positive. Slope's definitely positive, so we should come up with a positive value. Does it look like the slope is greater than 1 or less than 1? Less than 1. So we're looking for a number that's probably less than 1 that's positive for our slope. That's what we're looking for, the output. Very simply here, what we're going to do is we're going to identify 2 points. Our first point, P, is going to be an x value of 8. What is the y value? 3. How'd you get that? You plugged 8 into the function and it produced 3 for you. Very good. For Q, okay, I'm not going to choose, like, say, 9. I'm not going to choose 8.5. I'm not going to choose 8.1. I'm going to choose X because we're going to allow that to change. What is then my Y value? If you plug X into the function, what gets produced? Simple as that. And so we are now going to write the slope out. Y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Everybody okay with that? That's our slope function. We're going to type that into our graphing calculator. Okay?
Oh, thank you. Oh my gosh, mine did it too.
Why only a T?
Hello.
Yep, sorry you guys, you came out of parametric mode from last year, so here's what we're going to do. We're going to go to mode, and you're going to get out of parametric mode and polar mode by going down to function and pressing enter there. For calculus, we will be in radians 100% of the time for this class. There's only one problem during the course year where we go into degrees. Otherwise, we'll be in radians all the time. We go into our y equals, and now you need to make sure that you enter it correctly. A lot of the mistakes in this lesson come from you not entering it correctly into your calculator. So since we're entering a fraction, let's put parentheses on top. We then have the square root of x plus 1. I'm going to end that, and then we subtract what? 3. That's my top part of the function. I'm going to divide that by the bottom part. I have to put parentheses around the bottom. It is going to be x minus 8. Okay? That's my slope function. Remember yesterday where I had you guys manually compute? Some of you guys got out your phones and stuff. You're computing the slope by hand. We're not going to do that. We're going to use graphic technology to help it be faster. You guys good with that? Okay, so here's what we're going to do. We're going to go to our table. And what we're going to do is we're going to get x, let x get closer to our x value that we want to approach. What's the x value in the problem that we're trying to approach? What is the x value we want to get closer to? 8. We're trying to get closer to 8. So I'm going to enter the number 9. Okay? I'd like to get closer to 8 than 9 is. Somebody give me another number to enter. 8.5. Good.
I think I messed up my calculator. Could you help me? I tried to like clear all the stuff I had in here and I deleted my Y.
I did too.
Oh, it completely deleted it.
Yeah.
So I just put it back.
Yep. I want to get closer to 8 than 8.5. What can I enter? 8.1?
It's okay.
I want to get even closer to 8 than 8.1. 8.01. Or as Danny said, 8.001. And if you go ahead and highlight those y values, you can see a little bit better because it draws the decimal out even further. 1.662, 1.6662, 1.6666. Anybody want to guess what this is headed towards? If you're not convinced, type it in again. 1.666662. This is going to 0.16 repeating, which is the decimal for 1/6. Now you don't have to write, I mean, once you can see, is everybody, as we look at this, can you see that those decimal values are definitely, it's headed towards 1.6 repeating as we move along? So that's what we know our slope is going towards. So within this work right here, the limit as x approaches a value of 8 is equal to 0.16 repeating, or 1/6. Okay? Now here's the interesting piece. Watch what happens if you would plug in 8 for x. 8 plus 1 is square root minus 3, 0. 8 minus 8, 0. So we're accomplishing the task of 0 divided by 0. And it produces for us in this situation 1/6. Let's write the equation for the tangent line. What two things do you need in order to write an equation for a tangent line? Slope is 1/6. What is the point that it goes through? It touches at 8,3. So we will go ahead, y minus 3 is equal to 1/6 times x minus 8. I will distribute. Y minus 3 is equal to 1/6 x minus 4/3. I will add 3, otherwise known as 9/3, over to the other side, and I get y is 1/6 x plus 5/3. Now, I've gotten to know you guys pretty well. I know what you like and don't like, and I know that you like to know if your answers are correct on the test, right? So let's see if we can do a graphical check here and verify that this is in fact correct. Please go to your calculator and go into y equals. This is not our function. This is our slope function. I don't want to see that graph. We just use that to come up with the slope. The function that I want to see is the square root of x plus 1. That's the graph I want to see. And I want to compare that to the line that I have, which is 1 divided by 6 times x plus 5/3. If I graph those two, the line should be what to the graph? Starts with a T, should be tangent. We check the graph. Ooh, check that out. Does the line look to be tangent? Absolutely. If I changed something here, if I went into my my y equals, and instead of 5/3, suppose I made a mistake and suppose that 5 was an 8/3 and I went to graph it. If that was what you ended up with on the test, would your answer be correct? No. Suppose you're in y equals, instead of plus 8/3, suppose you have 8 minus 8/3. Again, you can see that that does not line up the way you want. In fact, if you do the plus 5/3, it hits just perfectly, and we know that our answer is correct. Touches once. We want to do one more example together, and then we want you to start to explore on your worksheet and try that, okay? Let's do one more. Find the equation for the line tangent to the curve at y equals tangent of x, and x equals pi over 4. A for the day. Who remembers pi over 4 in degrees? 45. All right, look at that. We learned some things last year. You know we did. Point on the line. My p, I've got my x value is what? Pi over 4. And then if I plug pi over 4 in, who remembers the tangent of 45, or the tangent of pi over 4?
One.
It is 1. remember, okay, so Jacob, good job, root of 2 over 2. Remember that this coordinate right here is the root of 2 over 2 and the root of 2 over 2. And tangent is the y value divided by the x value. So if you divide those, you get 1. Okay, I walked you through the first one. You help me here. What is my Q point? X, and the y value is? Tangent of x. Good. My slope function will then be tangent of x minus 1 over x minus pi over 4. We're going to use that to come up with our slope. So we'll go to our calculator. We're going to get rid of all these pieces. I have tangent of x. Whoop, I got to put my parentheses around it. Tangent of x minus 1 divided by x minus pi over 4. Let's make sure we've got that. Everybody okay with that? All right. What is the x value that I'm approaching? Pi over 4. Try and get close to pi over 4. I don't really know what pi over 4 is a decimal, so I'm just going to have to divide that. Pi divided by 4 is 0.785398. 0.785398. So that's the value that I'm going to approach. The limit as x goes to pi over 4. Okay? So I want to get close to that value. Now, Danny brought up something before. I just want to make sure we're careful with that, okay? I go to my table here. What's a number that's close to that 0.7 whatever? 1, sure. What I don't want you to do is I don't want you to type in a decimal really close to it right away. Creep up on it gradually. That's the concept of the limit. What's a number that's closer than 1?
Closer than that.
0.8 is closer, right? What's closer than 0.8? 0.79? What's closer than 0.79? 0.795. And you could continue on and write in this decimal, 0.785, excuse me. So 0.785. And you could continue to, add this decimal 0.7853. What do you think it's headed towards?
1.9.
Yep, and 1.9 repeating is the same as? Yeah, same as 2. 0.785. And then what was it after that?
398.
398. We go ahead and continue on. I mean, it's really getting really close to 2 right here. As you kind of look at your data, headed right on in there. If you type that all out, looks you get 9s, or continuing across, getting very, very close to the number 2. Now, suppose on your test you wrote 1.999. You didn't write 2. I'd give you credit. You have the idea, but without a doubt, this is going to 2, and we could become even more confident of that. So good. We have 2 is our limit. So our slope is 2. In order to write our equation for our tangent line, what we need is a slope, and we need a point. The point that we pass through is pi over 4, 1. That's the one spot that the line goes through on the graph. And the slope of the graph is 2. Okay. Y minus 1 is equal to 2 times x minus pi over 4. Y minus 1 is equal to 2x minus that pi over 2. And then we could just add 1 to the other side, right? So I'll just write it, for lack of a better option, y is equal to 2x minus pi over 2 plus 1. I'll write it like that. Okay. I'm going to check this graphically to see if it, in fact, touches tangent. Do I want to graph that?
No.
No. So I'm going to take that off. What is it that I do want to graph? I want to see the graph of tangent of x, and I'm going to see if my supposed tangent line touches that just once. My tangent line, we said, would be 2x minus pi over 2 and plus 1. Go ahead and sketch my graph, and I can see this tangent graph you remember from last year. And if you're not convinced, you could look at over 1, 2, or at pi over 4, excuse me. I zoom as my window. I'm going to zoom as a box.
What's yours too?
Mine's still loading. Just give it a second.
Oh my God.
I didn't also forgot the third one, so I just have the 2.
I don't know what she's doing.
Which is weird.
Did you press
I
pause
didn't.
on
I
your
didn't type
screen?
in the. I didn't type in the third one yet. Oh no, it's still. Now I gotta wait for it.
Take a look at it. Take off this one.
What was it?
Yeah.
You got 2x minus pi over 2
Okay.
plus 1. Are you convinced that this tangent line crosses the graph
Okay, now I
exactly
got it.
once?
Yeah, but what about when it crosses it down here? Because it's 9.
Good point. So when we talk about tangent, we're saying that it touches the graph once in that immediate area. It's possible that it will touch somewhere else, but in this immediate vicinity, it touches once. That word immediate gave mathematicians a lot of frustration for many, many, many years. And so it took about 1,000 years before they were able to resolve that. We'll be looking at that immediate idea later on.
My graph does not.
Oh, it doesn't? How come?
I don't know.
I would say it looks exactly like what I have.
You just have to zoom, right? Oh, you have to zoom in.
So I zoomed in to find that. Watch if I do, just watch. Zoom 6, if I zoom standard, now I have what you have. So I just wanted to see that a little bit more closely. That was it.
Yes. So mine's a little bit kind of like that, but it just looks wonkier. I don't know if that's just because of its.
So yours is only just because of TI-83. You just got these asymptotes that sit in there, but without a doubt, it touches it. If you want to
Okay.
see it, you would
Yeah.
zoom in. So I gave you guys a few varieties of functions there. You guys have your homework with you? You guys are ready to start working through that first worksheet. And these are the types of problems to be doing. Identical to this. You have 3 problems on the front. You have 3 on the back. You just want to find the slope. You don't have to sketch a super accurate graph. The graph is really for a check. I'm not trying to punish you by making you graph stuff. I want it to be helpful. Again, I know the content is new. This generally goes very, very well by the time we get to test time. Test scores are very high usually on this one. So I'm going to let you guys kind of go to work. I'm going to post an answer key. And let you guys ask some questions. We are out of here at 10:01, so you've got about 13 minutes. It would be awesome if you could get, say, at least 2 of them done, okay? And again, just careful as you plug these into your calculator, that's where people seem to be making mistakes.
So when you plug it in, the graph check is basically just check that it touched.
Yeah, that's to say, hey, we did it right.
Okay.
Okay, make sense?
Yeah.
Do you have a question?
No.
Jacob, you better call me Sunday and be like, "Back your calculator or I'm not gonna down your."
Oh, I will. Tonight, actually.
I work tonight, don't call me.
You know when you get back, like,
Okay.
I'm making you get up.
Check
Out of
away
your
for
bed.
60.
Yeah,
Right
when
I get in bed. Call.
get up right now.
I think so, yeah. And then it's just always y.
So you go P, so you gotta figure out your point. So,
Yeah.
like this one, we knew it was 8, so this one we know is 1. And then the other one, we have to plug it in, so the 1. Yeah, so 1 squared is 1, minus 6 is negative 5 plus 2.
If you wanna know the
negative
back,
3.
it's
So we know the other one. Did you actually not know, or are you trying to trick me?
Both, I guess.
Okay,
I'll try.
and then the Q is
Well, yeah,
X, and then the whole other thing, I guess. Right, X squared minus 6X plus 2. Oh, I should have put that down. Whatever. And then you gotta do your slope function. X squared minus 6X plus 2. And then you're gonna do plus 3 because it's minus a negative 3. And then you're gonna go and do X
I need to figure out, get that figure out.
Good second. So that's negative 3, but then subtracting it, so.
How do you know what numbers we're using?
So this is the first part,
You always try to get those. But what are we
and it's minus negative 3. And then you're gonna put that in your calculator. I really don't know.
I don't really know.
And
You do.
I'm going, y'all.
But it's broken.
Bree, are you glad to sit next to Ava this year so you don't need to help me? I'm ecstatic.
This is what you need.
Well, I don't know, cause is it approaching negative? Well,
I should do
What
do
is
you
it
think
because
is
your
fun?
fractions aren't simplified? If you simplified that, would it be this?
Oh, shoot.
Oh, like if you plugged in like a negative 99 divided by.
Oh, is it the
Right.
y
So
minus
you get-
y2 minus y?
Yeah, put parentheses
I think
around.
you're in like,
You can grab
we need to
it.
go into mode.
I am putting parentheses. I'll show you how I did it, but I don't know if that's right.
Yeah, I believe there's a.
I don't know if you have to, but I'm just gonna do it because it doesn't hurt anything.
I mean, classic, yeah.
I don't think I can. Okay.
But it's really plug it in.
How did we do this again? Did we put in like?
Oh, boy.
Yeah.
Wait, no, I think you plugged in this actually.
1.5.
Yeah, you plugged it. You plugged it. Just go.
Yeah,
why don't you just go ahead?
This is closer right here.
Oh.
Oh. So, okay.
We're going to mode.
I can't do so these are all
So
So obviously, so you're trying to get to, then you know it's negative 4. Is that what you just said?
That is what I got.
So
Wow.
answers
So what you do is you see that that's the limiting, the 1
There you
and
go.
X. So you're trying to get as close to that, but not reaching.
I'm trying to get to 1.
So what I did is I plugged in 2, and then you start going down.
Did
You get to that, and then you get negative 4. That just means the graph is changing.
Because it's already, this is a
So-
negative 3. When you plug this all
Then
in,
you
negative
gotta
5,
go
it's
to
just
the
negative 3,
line.
so it would be plus 3 instead.
And then go to
You
so
will.
much. Yes, it's X. Yeah, it's just X. And then So this is actually how it sounds when you're doing my homework.
Like all these voices at the same time.
No, it's just me talking to myself.
No, so like actually, like you're in your, no, so you
So
actually do
actually
this.
you do this,
And then you do that.
and then use the same point that we used last time.
There you go, there you go.
And
That's
then,
the
I'm forgetting what we
function.
do next. Now we gotta do this. Flat.
I believe.
Oh, shoot.
Want to use mine?
Do you wanna use this one?
Maybe it's not.
I
Posting the
finished-
answer key right
Hold
here.
on. Wait, you guys might finish this part. I can pass on my. Haley. I don't know how to do this right. I think I would just keep. Yes.
Okay, good. So which one are we doing? Right here?
Yeah.
Okay, so
did you
we've
plug
got
in- You gotta plug in that. Yeah.
y equals, so this is your problem, is that the +3 is still
Oh,
in
it's
the
a negative
numerator.
I mean,
Okay, you're
Therefore,
almost
your
to where I am.
parentheses must be around
I just
that.
Negative
accidentally mixed
six.
these two up and I was like, this doesn't
then we gotta go.
We have to have the +3,
Isn't it x squared? It's x squared.
so the whole top is in parentheses
Negative
now.
x not.
And
Yes.
now the bottom, x
Got
squared.
it.
So now it's where we put the table. There we go. See that? So I would say that that's usually the majority of the mistake sometimes is people don't include the whole thing at the top or they don't have the whole thing. So now you can see as you look at your numbers, we're getting closer to 1. You've done an excellent job there. What is the y value approaching? -4. Yeah, exactly. So -4 is going to be our slope.
The tangent line, that's what it's.
Vertex.
Is that what
This is what I can.
Good job. Yeah, that's a tangent line, but obviously the actual curve, this thing was probably looks like,
I calculus frozen.
something like that.
Yeah.
So tangent to the curve,
Okay.
that's what we tell them is right,
Okay.
is we're taking
Great.
-4.
And then you just delete the.
So
Plus
one is
one.
not gonna
Because
count
you
because
have
that's
to
the
get two
line.
x
I just
squared.
trying to get you
On.
as
Minus
close to
6x
the left-hand side.
plus 2.
So what you start
So
with is
you
you're
graphed a
gonna
line,
start with
which is great, but
And then
checking
you're
to
gonna
see
go like
if
one
it is
point.
actually tangent to our
And
curve.
you're gonna get like slowly closer.
See, that's what
Till
you
my
want
peak
us.
gets 1.1, and then
Oh,
you see
okay.
how it's
Good point.
going, you can see the trend how it's going towards.
Instead of going through.
So then you're gonna put in
Question?
like that.
No,
Yeah,
I'm
you
trying
need
to
a
put
calculator.
calculator.
This one's not loaded.
Yeah.
I
might have one here.
Can it be like super rough draft sketch?
Yes, it can be a very rough sketch.
This one here.
There you go.
Hey,
Oh, that's too much, too much.
Starts down there on the graph. But that's not.
Yeah.
Oh, wait.
just x squared minus
That's what I'm saying.
2. So then, can you see? Buddy?
Sorry, I was
Oh,
just.
But
Sorry.
can you see how it got lost?
Sorry, Haley.
That's okay. You can use
Oh,
this
wait,
one. I can do a problem and then you can do it. Are you sure? Yeah.
Yeah.
Because it's not for, I didn't do mine either. Well, I gotta have mine, it just like doesn't work. Oh. I gotta ask a suggestion, but apparently we can have it. I can use
I
Jacob.
just-
Yeah,
Because
I'm sorry, I don't
how
have
to do it.
one.
That's okay. You can use mine. Did I graph this right?
Yes,
Like-
100%.
Okay.
Perfect. Yep, awesome.
After I'm done with this one, I'll just do it with Jacob. So you can
Okay.
use this one. If it's.
Yep.
I don't know if I'm having a brain fart or what, but I'm trying to grab this grab.
I did that too. And then mine is.
Yeah, you just sketch graphs just like that, that's
I
fine.
can type
Yep,
it.
Yep. So you make a rough sketch, you don't have to do it exactly. You're fine.
It doesn't have to be exact.
No, no. The graph can be very rough. I want you to spend your time on the other part.
Ew. Jacob, come here.
Sorry.
Oh, boy.
Okay, we gotta get you through the first one. Then we can- No, don't. Okay, so you got 4 for that. So now we gotta make your tangent line. So what's your slope? Yep.
So we're supposed
So
to
write it
write it
down.
down and then check our graph.
Yep, yep, good, yeah.
Okay. Yeah.
Yep, hit graph there, okay, so that, yes, but you're checking it not against the slope function.
So this slope function is not going to look pretty at all.
Yeah,
But we
mine's
wanna
already
check
all
it
in there,
against
so you might wanna clear it out. if you want
X
to do it.
squared,
Okay.
or is it plus 6x? Minus
Minus-
6x,
minus-
plus 2?
Plus two, yeah.
So we want to see, is that line in fact tangent to that curve? I press graph,
Like that.
there's my line,
Yes,
and my
sir.
parabola comes, yep, see how it
You
touches
wanna
real nice?
continue to
And you just make a
solve
general
one.
sketch of that, doesn't have to look perfect, just a
You got
general
that.
sketch.
And then you can, that's what
I think
should
I've got
on
it
the
down now.
calculator. This is kind of fun.
You will teacher.
No, I like the,
You like the parabola things, the
Yeah.
swoopy things.
Okay, good.
is it just these three, that's all we need to do?
And then there's 3 on the
I
other
like
side.
that.
All for this
Yep.
weekend?
Yep.
Okay.
So we plug in the tangent line and
Oh, there we go.
this,
So are we on
the first one.
the, okay, so yeah, you plug in the,
The whole thing.
not that anymore.
Just
You
this.
delete that one and then you plug in,
I got it.
the first part,
Okay.
this part, and then the,
Ooh,
Okay.
ooh.
I'm trying to see where I'm wrong.
Right,
That's
and
no
so
good.
Here, if we do multiply by the negative 4
You
from
plug
the
it
top,
all, they don't provide
you
it.
subtract 3, you get 1.
And then you go to
So this
table,
is
right?
the graph
Yep.
right
Yeah.
here.
But then it already has everything.
Oh, I don't know.
You have
I
to
did
put in your
plus
X
four.
values
I finished it, yeah.
No, your graph.
So
is-
you just, yeah,
Yeah, you
I
can
calculate
go
the
back
X
and
values,
do
I
yeah.
had on my paper,
Oh.
that's just not what
Perfect, good job.
Yep, make sense?
Yeah.
Okay. Make
Yeah,
sense?
it's
No, he said just rough.
I keep getting like just 11,000 or something for this one zone.
Can't do that.
Okay, so we'll probably just plug in something in
What I put on my
incorrectly.
paper was different than the
How can we get done?
So you're gonna minus
Oh.
negative 5, which would then mean a plus 5.
It should always be.
Do that?
Yeah.
I need to put this
Thank
together.
you.
Yep.
You
It should
guys
always be
definitely
close to that one. You gotta do the rough
Yes,
draft,
ma'am.
which way.
Okay, folks, we're gonna, Belle's gonna go here in a little bit. As of right now, we have a cross-country meet on Monday that I will be going to set up for. However, it's possible that cross-country meet gets moved to Tuesday if there's too much heat. So if I'm not here, there will be a short video for you guys to watch to kind of do the next piece. Otherwise, that video would be on Tuesday instead. So just play it by ear. I wrote down that we did the same thing last year and it went really well. And you guys are more intelligent than last year's class, so
Oh, yeah.
Oh, for sure.
For sure.
shouldn't be any problem.
If I forget my calculator again, I'm just gonna leave.
And
I'm gonna
It's
run your
so
phone.
weird.
What?
Cause I get,
Put on a
I get
reminder.
study hall.
My
No,
phone is-
I am for reminder.
And then class.
And if I forget, we all die.
It's a new game.
No, don't do that.
I can't wait till we.
No, I just got home with this weekend, so I'll remember to put it in the